Welcome back to 11.1. Now remember I told you when I did the day one of 11.1, the book really wants me to teach these 3 days. I'm going to do this for 3 days. They want me to do this in one lesson, which I think is just silliness. So we are going to make sure that we do this the right way. We're going to take 3 days. Now the first day yesterday we had monomials, nothing factored. Today we're going to reintroduce that concept of monomials, but we're also going to add in GCFs. Tomorrow, we're going to have monomials, GCFs, and we're also going to have to box. And then we're going to take some days just to kind of practice that a few times over and over again. We are still I'm sorry, that circle did not go to the right section. We are right here. We are simplifying and reducing rational algebraic expressions. I will take that circle and change it accordingly on yours. In fact, I'm going to do it right here since I'm sitting here in front of my computer. Okay, sorry. All right, yours will have it correctly. Okay, now let's move on. So the question is, do you remember from yesterday, what is a rational expression? I'm so glad that you're wondering. A rational expression, do you remember? It is a fraction. That's what rational means. That has numbers and or variables. So gone are the days. Remember when you used to just have like 3/6 and you made that 1/2 and you were like, yeah, that's cool. Now we're back to the days where you have 3x squared over 6x and you change that not just to 1/2, but to 1x over 2. And that's what we were doing yesterday. Now we're going to take a look. We have one more fill in the blank. Yours will be typed. Today, you might need to factor them before you start. And let me just tell you, I think I made almost every single one of them factorable. Now, today you are not going to have just monomials. You will need to find the GCFs and you are going to then reduce after factoring. Let's move on and see how we do on number one. Maybe what I'll do in yours, I'll move those up so you have more room. Now, as I look at number one, I see that this is a binomial and this is a binomial. So what I'm going to do is I'm going to check for a GCF. Maybe that's why I left you room up here. So what goes into 10 and 14? Well, I know that 2 goes into 10 and 14, and I see that they each have a y. So the GCF of the numerator is 2y. Watch how I'm going to factor this. I'm going to write 2y here, and then I'm going to write what we have left over. If I divide this by 2, I get 5. If I take away a y, that's y squared. That's how you do GCFs. Minus, if I divide this by 2, I get 7. And if I take away a single y, I just have a 7. Now let's do the same thing on the bottom. GCF on the bottom. Today we're focusing on GCFs. So what goes into 6 and 18? 6. And let's see, they both have a y, see that? And the smallest one is y squared. So the question is, what happens, let's write that here. What happens if I divide 6 by 6? I get a 1. What happens if I take y3 and I take away the y2? I'm just left with 1. Now divide this by 6 and I get a 3. And then y2, take away y2, and there's no y's left. So we have found our GCFs. It's almost like we have a new problem now. Can you see the new problem right here in the middle of the page? Now what we're going to do is we need to focus on the monomials in the front as their own thing, and then the binomials in the back as their own thing. Okay? So I am going to ask you guys, do you remember from yesterday? Let's focus here. Remember you needed to see it as like 2/6, right? And then I need you to see it as y over y squared. So how did we do this yesterday? Well, we would put 2/6 in our calculator, and that would give us, oh, that's crooked. I'm sorry. I have an issue. That would give us 1/3. So 2/6 in our calculator gives us 1/3. Now, this y goes away, and this would just be y to the first. So that's how you do the monomial out in front. And then the binomials don't match. See this binomial and this binomial? Since they don't match, we can't cancel them. So I bring it down and I'm done. So you can see today really kind of like ups the ante a little bit. So we take our GCFs out and then we cancel anything in the front that we can. Let's try again. So the GCF on the top, I'll try to stay consistent with the blue. The GCF in the top is a 3. Now when I take a 3 out, that's 3. Okay, so it's like, what is 3 divided by 3? What's a 1? And then the x has to stay with it because you're not taking the x's out. What's 9 divided by 3? Well, that's a 3, and there are no x's to worry about. So the top is 3, and then 1x take away 3. Now let's do the bottom in red. What's the GCF between 7 and 21? Hopefully you're saying 7. And then I have x squared and x. So you have to take out a single x. You take out the smaller one. Now, guys, we're going to talk about dividing, okay? What is 7 divided by 7? 1. What is x squared? Take away an x, a single x, minus. What is 21 divided by 7? 3. What is x? Take away an x? None. No x's left. So our denominator is this. Now we have a brand new problem, and it's time to cancel anything that matches. Well, look out here in the front at your like GCFs. Does 3 over 7 reduce? Like if you do 3 over 7 in your calculator, does that reduce? No, it doesn't. And there's just a single x. So when I have 3 over 7x, none of that reduces. That stays put. But you see how these ones match identical, the binomials? That means that they go away entirely. So our only answer is 3 over 7x. Let's go to the next one. Let's find the GCF on the top. Did I make it hard? I'm thinking 9. Yep, 9 goes into 18 and into 45, and this doesn't have an x, so it's just 9. If I divide this by 9, I get a 2x. If I divide this by 9, I get a minus 5. So my numerator is this. Now it's time for my denominator. What is the GCF of 12 and 30? I'm thinking it's 6, right? Yeah, 6 is the biggest thing that goes into both of them. So definitely a 6. And x and x squared, just a single x. So now we have to do some division. What is 12 divided by 6? 2. What is x squared? Take away an x, a single x. Plus, what is 30 divided by 6? 5. And then a single x, take away a single x, is none. So the denominator is this. It's hard because sometimes students think that GCF is like 3 instead of 6, and then it can get very complicated and it looks like it doesn't reduce. So here's the new problem. I want you to actually notice I did this on purpose. These do not match. One's a plus and one's a minus, so they do not cancel. So as part of your final answer, you're going to put 2x minus 5 and 2x plus 5. They are not the same, so please don't cancel them. However, 9 over 6 does cancel. If you put 9 over 6 in your calculator and you reduce, they both divide by 3, so you would end up with 3 over 2. Now what about this little lonesome x? Well, he's just right here. So this is the ugly answer. Number 4, GCF on the top. What goes into 5 and 20? Hopefully you're thinking 5. They both have at least a single x, so that's what we're going to bring out. Now it's time to divide. What is 5 divided by 5? 1. And then what is x squared? Take away an x, just an x. Minus. What is 20 divided by 5? 4. What is this x? Take away that x? None. Now for the bottom. GCF. What goes into 25 and 50? Hopefully you're thinking not just 5, 25. And they don't both have an x, so just 25. Now it's time to divide. What is 25 divided by 25? 1. And that x isn't being divided by anything. What is 50 divided by 25? 2. Not 25. I'm wondering if some of you thought it was 2 or 25 because you were subtracting, but it's 50 divided by 25. Now it's time to write our answer on the side. I think I did everything right. So here is your new numerator. Say that 10 times fast. Here is your new denominator. So I need to look at 5 over 25 like we did yesterday. Put that in your calculator and you get 1 over 5. And then this single x is one of a kind, so he just comes down. These do not match, so they have to come down like this. If the binomials don't match, you do not cancel them. Whew, I hope you guys are doing okay. Now for this one. Oh my goodness, look at that number that she used. I should have put that in the, no, I like having a problem in the middle. Okay, so this one has a GCF of 400. 400 goes into both of them, and a y squared because they both have y's, but we picked the one that has the smaller exponent. So if I take 400y squared out of there, let's divide by 400 and get rid of those crazy circles. 400 divided by 400 is 1. y3 take away y2 is y to the first plus 800 divided by 400 is 2, and y squared take away y squared is none. So our numerator is this. Let's see. Sorry about that scribble. That's our new numerator. Now let's do the denominator. The GCF of 8 and 16, I know maybe some of you are just thinking 2 or 4, but it's actually 8. The GCF is 8. And this doesn't have a y, so just 8. So I need to divide. What is 8 divided by 8? 1. And then this y, take away nothing, is still a y. Plus, what is 16 divided by 8? 2. And there's no y here to worry about. So my denominator is this in factored form. Excuse me, please. Oh, do you see it? Does anybody see the binomial? Those match identical, so they can cancel out. They match. Yay! So if they match exactly, you can cancel them or reduce them. Now what we need to think about is 400 divided by 8. Now I haven't actually used my calculator today in my lesson. I've just been doing the math in my head. So let me show you how. You're going to do 400 divided by 8, math, enter, enter. And it's just a clean cut 50. So we'll just put 50 here because it was bigger there. And then this y squared is just kind of all by his little lonesome, isn't he? There's not like another y down here to cancel it with. So our answer is just 50y squared. We don't even need that silly fraction bar. All right, one more, okay? Let me get rid of this here so I have more room. We got this. Whew, GCF on the top. Now, because I will move those down on yours, okay, so you can write it above it. I don't want it to get mixed up with everything above. The GCF of 2 and 2 is 2. And now let's look at the x's. I have x. Are you catching on? Do you remember? Is it x4 or x3 that I should pick? It is x3. You always pick the one with the lower exponent. So I'm going to do, okay, 2 divided by 2 is 1. x4, take away x3 is x to the first, minus 2 divided by 2 is 1. x3, take away x3, no x's left. All right, GCF on the bottom now. So GCF on the bottom. And again, I'm going to move yours, so if you want to write it, you can. Let's see, what goes into both of those? Definitely a 2, but even bigger, a 4. And they both have an x, so do I pick x squared or x to the first? I pick x to the first. Okay, now it's time for some division. What is 12 divided by 4? 3. How about x2 take away x1? x1. Minus, what is 8 divided by 4? 2. And what is x1 take away x1? No x's left. All right. So now what we're going to do is write our final answer. So unfortunately, those don't cancel because they're different. So when I draw this fraction bar here for my rational answer, I'm going to have 1x take away 1 and 3x take away 2. Now, did you notice I didn't carry that 1 down because it's like implied, okay? How about 2 over 4 then? What did you learn back in elementary school? What is 2 over 4? In your calculator, math, enter if you're not sure. Hopefully you're thinking 1/2. How about x3 and x1 from yesterday? How about x3 and x1? Well, that should leave x2 at the end. So there's your final answer. What we're going to do now on this front page, though, is remember how the keystones, they are not going to have a whole bunch of ones where you don't need them. We're going to go through and we're going to find them and get rid of them where we don't need them. So let's look at number 1. The keystones will not have that one, or that one. The keystones will not have, oh, they'll have everything there. Let's look here. There's no weird ones on that one. Aha, here's some. The keystones won't have any coefficients of 1 or exponents of 1. Let's look right here. That's fine. And here, they're not going to have this coefficient or this coefficient of 1. And now, some review, because these will definitely pop up on the keystones, maybe even more than what I went over for your new lesson today. Remember, this is set up. It says solve the system. Okay. So you're going to take this number and put it here, and this number and put it here. I know they're negatives, but here's what you do with the negatives. You have a double negative. You can't change those. So we need either 3 positives and 1 negative, or vice versa, 3 negatives and 1 positive. So since we have 2 negatives we can't change, we may as well just put an extra one. So we have 3 negatives now. When I say 3 negatives, I mean 1, 2, 3. I don't include those. And I have 1 positive. Here we go. It is now time to distribute. This is called elimination. You learned this in the class previous to mine, so it's just review. When you distribute, negative 5 times negative 4 is positive 20x. Negative 5 times positive 2 is negative 10y. 11 times negative 5 is negative 55. Now for the bottom. 4 times negative 5 is negative 20x. 4 times negative 2 is negative 8 and y. And 4 times 7 is 20 and 8. 28, not 20 and 8. That sounds silly. Now that was step 1. Now for step 2, we combine or add straight down, okay? So the x's should cancel if we did it right. We get negative 18 when we put our y's together, and because I do not want to redo my video, what is negative 55 plus 28? Okay, negative 27. I'll just keep that up there. Ooh. And so I would call, so let's see, step 1 was here, step 2 was here. Step 3 is solving this, so we're going to divide both sides by negative 18. So we get y equals 1.5. Now, if you want to, you can math enter that, just in case the keystones need it. You could also do 3 over 2 if you prefer. Sorry if you hear the students in the hallway. I mean, why not just randomly scream down the hallway? That was step 3. Now last, step 4, okay? You can pick either of those original equations. I'm just going to pick negative 5x. They are very loud, aren't they? Okay. Some people like to learn. All right. That wasn't very nice, was it? So we're going to make y whatever we just got. What did we get, guys? We got positive 1.5. Okay. Oops, there you go. So it's negative 5x minus 2 times positive 1.5 equals 7. Let's simplify. That's negative 5x minus, what is 2 times 1.5? 3 equals 7. Now we're solving for x, so add 3. That's usually where kids start getting comfortable, is this step right here. So negative 5x equals 10. Remember, this is just review. Don't think you're learning anything new. Just trying to review so it's not like, you know, been 1,000 years when you get to the keystones. Divide by negative 5 on both sides, and x equals negative 2. So when you go to the keystones, please make sure you look for the one that puts x first and then y. They might have it flip-flopped, which would really stink if you went through the whole, sorry. Make sure they might flip it. Like they might have one answer where 1.5 is in the X spot and vice versa. So just be careful that you remember X comes first and Y comes first. And that's totally fair. Like we should know X comes first. We should know how to solve systems. Um, so I'm hoping that you guys felt comfortable taking out GCFs and then solving systems as review from a previous class.